Hello everyone, thank you for joining me today for the latest in the Global Mapper webcast series. My name is David McKittrick, Senior Applications Specialist here at Blue Marble Geographics. The topic of today's webcast is rendering vector data in Global Mapper. And basically what we're going to be looking at is the process of changing the display. We can do that in a number of ways. We can do that manually. We can change the appearance of features on the map based on a manual process. Or we can have that appearance be derived from some of the characteristics of the data, perhaps an attribute. So we're going to take a look at a number of different workflows. We're going to take a look at some very specific data. We'll actually look at the US counties as a layer, and we're going to explore different ways that we can change the appearance of that data. Now, before we get started, a couple of housekeeping issues. Well, obviously this is a recorded presentation, so we do not unfortunately have the option of live questions and answers. You can obviously, as always, email us with any questions you have. I will include the email address at the end of the presentation. I've also put it in the description right below this video if you're watching on YouTube. So it's going to be geohelp@bluemarblegeo.com. And again, you will see that confirmed at the end of the session today. If you want to explore some of the functionality of Global Mapper in more depth and maybe interact with some other users, we always recommend visiting the Global Mapper forum. Within the application, you can go to the help menu to find a link to the forum, and you can register there and post questions, or better yet, you can answer questions that others may have posted there. Now, before we get started, we'll take a quick look at some of the specific topics we'll be looking at today. We're going to start with the basics. We're going to import a shapefile to begin with. As I mentioned, we're going to be looking at a shapefile denoting the outline of the US counties. You'll see a little snapshot of that on the left-hand side of my screen. And we're going to begin by exploring the process of manually changing the appearance. Anybody who has imported or loaded a shapefile into Global Mapper will know it appears in a very generic way, unfilled, black outlined polygons. And we're going to explore different ways of changing that, again, starting with a manual process. We'll take a look at feature types. These are built into Global Mapper. They are a series of pre-configured vector settings that can be automatically applied either during import or manually applied to collectively change the appearance based on the assignment of whatever that feature is. It might be a state, it might be a lake or something of that type. And you can pre-configure these feature types to have certain display characteristics and again automatically determine how your features are displayed. So we'll take a look at feature types, both the feature types that are pre-configured in the application, and we'll also take a look at how you can customize them and create your own library of feature types. It certainly simplifies the process of assigning colors if your intention is to do it on a manual basis. There's a very specific component that allows you to assign random colors, and we often look at this in kind of a lighthearted way. It creates a random patchwork, if you like, but there are certain practical reasons why you may want to do this. It's a simple differentiation of features within a layer. This will assign random colors or random symbology to each feature in that layer. And we'll take a look at where we can find that in the software. Now, to get into more meaningful workflows, we're going to start to look at applying colors that actually reflect certain variables or certain characteristics of the data. And we're going to do a couple of different scenarios. The first one's a relatively straightforward one, where we're going to apply colors that reflect a particular instance of an attribute. Now we're going to actually look at two examples. One is going to be based on the state within which each of these counties falls. We're going to have them display a color to reflect that state. And we'll do a slightly different one where we're going to do it based on a region. We've assigned each of these counties to be part of a region, and variations on the same theme. We'll see two different variations on that process. A little bit more involved is the process of assigning colors based on numbers. Now, obviously, when we're talking about states or regions, they are essentially common values that recur and are applied to numerous objects within the data. When you talk about numbers, it's quite conceivable that every object in a layer, every county in this case, would have a different number. So the same procedure would not work. So we have to differentiate the counties based on a display characteristic, based on a range of values, and we're going to explore how that process works and how you can manipulate those ranges or define your own threshold values to alter the appearance of the features on the map. So a little bit more involved. take a slight deviation, but another way of visualizing data. We're going to use our density map tool, or our heat map tool, it's often referred to visualize a couple of different variables within our data. One is the actual clustering of data. We're actually going to use some points for this example. And then we're going to take a look at a very interesting example where we can take a specific attribute and derive a heat map from the value in that attribute. Now, a lot of the workflows we're going to be exploring today are going to be derived from population or variations on the theme of population density specifically. This is going to give us a heat map of population. We're going to go through a procedure to create a heat map of the US that reflects obviously higher concentrations of high population counties. Again, slight deviation from the display process, the vector display process, but we're going to bring in another data visualization component here, and that's visualizing data on a graph. Now, this actually relates to one of the procedures that we'll have performed previously, where we assign colors to reflect regions. We're then going to generate a graph, specifically a pie chart, that will reflect the total population within each of those regions. And it is another way of visualizing your vector data that in a sense detaches the display of the attribute characteristics from the map and displays it in its own entity. And we're going to generate a little pie chart, and we actually can dock that within the map view itself. So it's a newly dockable feature in our multi-view setup. Now, finally, we're going to take a look at labeling, the process of assigning labels. Now, that's not the primary function of what we're looking at today. Obviously, we're dealing with display characteristics of visualization of vector data, but it would be remiss of me not to at least address the idea of labeling. At the very least, as you will see when I load up our data that we're going to be working with, you'll see labels assigned. So it's worthwhile addressing the process of labeling. I'm actually going to go through a kind of creative process to show you how you can manipulate labels and make them behave in a way that you want to. So I'll hold off on that for the time being. You can look forward to that one towards the end of our session, but we will take a very quick look at labeling. Now, as promised, most of what we're going to be doing today is going to involve a very specific layer. We're going to look at a shapefile. I should say this shapefile is a shapefile that contains areas or polygons. As you will see in a second, it's going to be the outlines of the counties in the US, at least the lower 48 states, with apologies to our friends up in Alaska and Hawaii. We're just going to keep this condensed into the contiguous 48 states. The processes I will show you are based on changing the display characteristics for those polygons. I'm not going to take the time today to go into the details of changing the display of lines or to changing the display of points, but needless to say, procedures are exactly the same. When we're talking about lines, we're obviously not talking about changing the fill color or the color of the polygon itself, but obviously the style and color of the line. Similarly with points, you're talking about the symbology of a specific point. So that said, we'll be specifically looking at polygons in our workflows today. So let's take a look at the shapefile in question. I'm just going to go to the File menu, and I have loaded this one up recently, so it's in my recent menu, and it's US counties. And what you're seeing on the screen now is fairly typical of what you will see in Global Mapper when you load a shapefile. There are going to be situations where the shapefile will have attributes that define its visual characteristics, in which case Global Mapper will read those and you will see them displayed appropriately. Indeed, there are other formats of data that will inherently have colors and symbology assigned. I think of CAD files specifically. AutoCAD, DXF files, DWG files will bring with them whatever display characteristics were established in AutoCAD or whatever the application was. So there are going to be situations where you will at least get some reflection of how the data was displayed in its original format. Most of the time you will not, and when you look, as we're seeing with our states, when you see those on the map, they are displayed in a generic way. We're looking at outlined polygons, black lines, and unfilled. It is also worth noting that we're seeing labels. At least we're seeing some labels here. We're not seeing them all. It would get very messy if we did. There's a decluttering process that is automatically applied, and we're seeing certain labels. Now, as promised in my agenda that we just looked at, we will spend a little bit of time later talking about labels and addressing labels. For the time being, and I have to remember I've done this, for the layer in question, I'm going to go to the options. Now, we will be going to this area of the software several times over the course of the coming workflow, so it's important to note how I got there. A couple of ways of getting to the options for a layer. From the Overlay Control Center, I can right-click, and you'll see the very first line item in my submenu here is Options. And you'll also notice double-click is an option. So you simply double-click on a layer, and it will bring up the options for that layer. So next time I get to this dialog box, I will be double-clicking to bypass the menu. Now, the only reason I'm coming here right now, the first reason, is to address this idea of labels. Their labels are currently displayed. As you can see, they will be on by default, but we have an option to universally turn them off for the time being. We'll address these later, but for the time being, we're not interested in labels. We'll simply check that option and click OK, and we're back to our generic display. Now, obviously, there's nothing inherently represented in this data other than the geometric shapes. At the very least, you may want to change the appearance universally. All of my states right now are this generic, dull, unfilled color. If I want to change these universally, there's a number of ways that I can do it. I can do it by defining a feature type, which we'll do in a few minutes. I can do it by using my digitizer and by selecting features, which again I'll do in a couple of minutes to demonstrate that process. Or we can go to the options once again for the layer, and we can click on the Area Styles tab. Now, if this was a layer containing lines, for instance roads or rivers, it would say line styles. Similarly with points, it would say point styles. In this case, it recognizes that there's only areas or polygons, so that's all I'm being prompted with. And you'll see the options here for defining the visual characteristics, which by default will use the default style. We'll deal with the classification or feature types in just a little bit. If I want to override that default for this layer specifically, I'm not changing any configuration in the software, I'm not changing the default for a particular feature type, I'm simply making the decision for this layer, I want to use the same style, and I can then define exactly what that is. And bear in mind, this will be applied universally to all of the features in the layer. So if I want to go for a solid fill pattern, you'll see while I'm here there are a number of other options: cross-hatch patterns, horizontal hatch patterns, and then we've got some very specific patterns. Sand pattern obviously is something you would use if we were maybe doing some outlining of deserts or something of that type. It's a very specific shader pattern to represent sand, similar with salt and coral. Chances are you're not going to be using that one too often, but you do have options here and the different ways of changing the appearance. Certain options in here will also allow you to change the color. So for instance, if I choose solid fill, I can define what that color is. Oh, sorry, there's no fill. Let's try solid fill, and I can define what that color is. And I'm just going to go with a generic red in this case. And we'll click OK. And you'll see a little preview down below that reflects what that will look like. Obviously a red color filled polygon representing each of the polygons in my layer. I can also define the border style. And again, it will be, as it has inherited from how it looked previously, a solid color. It's a 1 pixel wide line. And if I click on color, you'll see it's a black color. This can be changed as well. In fact, there are a number of different options for your border. Many of these are probably more appropriate if you're not applying a fill, where you want the border to be the distinct feature of the object. When you're filling the polygon, it might get a little messy, and especially if you have abutting polygons as well. But you do have options here, and these are inherited from our line styles. If we were applying this to individual lines, we would have the same options in there as well. So the important one to note here is null. If you want polygons that do not have a border, if you want polygons to which you assign a color but you don't need this hard border between them, then go with null. Null will basically be no border pattern at all, no border line style at all. It will be invisible. So that's an important one. Obviously dashes and dots are available in here with various combinations. I'm going to keep the solid line. We'll keep it at 1 pixel. Again, you have a number of options. And the final thing to look at here is transparency. It will be opaque by default. All of the features in this layer will be assigned an opaque pattern, but we can change this to whatever we want. You'll notice the color is not changing, but even the visual preview, if you like, the color intensity has dropped. I'm down to about 50% transparent here. We'll keep that as is. We'll click OK. And I'm just going to leave this window open and click apply, because we'll be coming back here and looking at a couple of other variations in just a second. Here we have a solid fill pattern, but it is a semi-transparent. Now obviously in this case we don't have any other data, so we're not seeing anything through the transparent layer. If we had imagery, for instance, or perhaps we wanted to display our vector data on top of a topographic map, then we would see that underlying feature in a kind of a muted form, a semi-transparent layer sitting on top of it. So that is definitely an option. There is another consideration that you may want to factor when it comes to the assignment of the opacity or transparency of objects in a layer, and that's for detection of overlap. Now, I'm actually going to close this window very quickly here. We'll be coming back in here in just a second. I'm very quickly going to draw a feature on the map. We'll draw a circle. Knowing that the features in this layer all have inherited the same color, we've assigned that setting to the layer, any new feature I add to this layer will also automatically inherit that color. So this circle I'm about to generate here, I'll just do it overlapping some of the southeastern states here, or southwestern states I should say. We'll make sure we assign it to the same layer, which is our counties layer. I'm going to delete this in just a second. We don't need to keep it, but just for visualization purposes, we'll assign it to the counties layer. We'll click OK. And as you'll see, it has also inherited that semi-transparent color pattern. But one of the consequences that we see here when we have more than one object, more than one vector object sitting on top or overlapping another object, it increases the intensity of the color. So a great way to visually detect overlap is to create a semi-transparent color for the features you're putting on the map. And very quickly, as you can see in this case, I can see where my overlap occurs. If there were other polygons overlapping, again, that color intensity would increase for every overlapped layer. You can actually rasterize this as well. You can export this as a raster layer, and you can run an analysis of the pixels in the raster layer to determine the degree of overlap. So there's a few different tools can be applied, going off on a little bit of a tangent, but that is an option. In terms of visualization, semi-transparent will give you the option of detecting overlap. Now, before I forget, I'm going to take that circle that I just created and I'm going to delete it. We don't need it anymore. So again, that process essentially manually assigns a color based on the layer. I'm going to double click once again to go into options. I'm going to go back to the styles and I'm going to go back to the default again, and we'll click apply. And we're back to our original display. Now I should stress as well, that is layer specific. It is also worth noting that any color assignments that have been applied are only applied within Global Mapper. We're not changing the characteristics of the external data in any way, shape, or form. That shapefile that currently resides on my desktop has not changed. If I wanted to change the characteristics of that file, I have the option when I export to add the style characteristics to the DBF file of a shapefile. But until I do that, I'm only changing how Global Mapper sees the data, not how it's originally stored. So another method for changing the display is to do so manually using the digitizer tool. My digitizer, my pencil tool, this is the tool that lets me interact with my vector data. I'm not drawing anything anymore, but you'll see my cursor. It says edit right down here, bottom left corner. So I'm going to select a polygon. I'll select one of these counties and you'll see it's highlighted with a hatch pattern. And if I right click, I have the option to edit. Now this is obviously very specific to one item that's been selected, but I have the option here to specify the style. You'll see it is currently using the default style, but I have the option to override that default and to define the color based on whatever it is that I want. So I can again choose from solid, hatch color patterns. There's my sand, salt, and coral again. I've got all sorts of options, and I can make that one polygon appear whatever way I want. I'm not going to follow through with that right now, but I do have that option. So it's essentially the same series of settings that are not applied at the layer level, but are applied at the feature level. Now, to go around the polygons in this layer and manually select them and change their colors is a bit of a laborious process. Granted, there may be situations where you universally select a number of polygons, perhaps everything that falls within a boundary or something of that type. The same process could be applied collectively. Again, right-click, once again, edit, and once again specify the style, and I have the full range of choices again, once again, for what's selected, not just at a singular level, but at a collective level. Now, anybody who has been through one of my training classes will probably recall at this stage I say, do not do that. What I've just shown you, it is awfully appealing to think, wow, I can create a very meaningful map by choosing features on the map and by manually changing their colors to reflect maybe some component of the data, some variable in the data. Don't do that because the manual assignment of colors pays no attention to any of the inherent attributes of the data. As you'll see in one of our future workflows coming up, if I wanted to assign a color that reflected one of those attributes, I can do so in an automatic way. Now, the benefit of that is it's foolproof. It's not going to make any errors. And also, if I change the attribute that is reflecting that color, it will automatically update the color with the new to reflect that new attribute. So do not generate thematic maps manually, is the moral of the story. While you can, I strongly discourage you from doing that. So we'll cancel this one for the time being, and we'll go ahead and deselect. Now, the other way that we can manually change colors is by addressing the process of feature types or assignment of feature types. What we've done up to this point is essentially choosing the polygon either collectively at the layer level or individually with the digitizer and choosing the color. We're going to take one step up and look at the feature type that's assigned. Now, for this polygon, or these series of polygons, this layer I should say, the feature type that's assigned is an unknown area type, and I can prove that with my info tool. If I select one of the polygons, it's off screen, I'll drag the window in from my second monitor here. You'll see that the feature type for this particular polygon is an unknown area type. It doesn't know what it is. There is nothing inherently in that shapefile that was smart enough to tell Global Mapper how to render the data, so it's dumped into this generic catch-all. That's why it appears, as I've described, with black outline unfilled. Within Global Mapper, there is a library, a pre-configured library of feature types that you can choose from to assign to features in a layer, either a pre-existing layer or to features that you draw yourself. That is controlled within the configuration dialog box. I'm going to use the little button here in my toolbar, the one that looks like a wrench or a spanner, depending on which side of the Atlantic Ocean you're on. I click on that, and you'll see three different sections of the configuration which are relevant for this process. One is point styles, which we're not going to worry about. Another is line styles, which once again we're not going to worry about. And the third is area styles, and we will take a look at area styles. Within this area styles list, you will see all of the feature types that come pre-configured in Global Mapper. Some of these you will use but not be aware of it. Certain things that we do with Global Mapper will automatically trigger the display of certain types of feature types. I think specifically when we're talking about lines, if you generate contour lines, there is a pre-configured line style that's built into Global Mapper so that your contour lines will appear consistently as a contour line should. Any of these can be changed in any way you choose. For instance, I have a feature type called county that's pre-configured, and right down below you'll see a preview of what that looks like. It looks like a black outline, slightly thicker line I think than the unknown area types, but I might not want that as a generic or as a default way to represent counties. I won't want to change that, and you have full control. Right here we can define for this particular feature type what that will look like. Now, I'm not going to get into that process right now, but instead what I'm going to do is create my own feature type. And this is something you may want to take a serious look at if you're doing a lot of work with vector data and you have a need to quickly and easily differentiate different types of features. Maybe you're drawing different types of agricultural land and you want to differentiate different crop types or different forest areas or different types of environmental area. Whatever it is that you're working with, you can create your own library of feature types that will consequently allow you to automatically assign the colors either as the features are loaded or as you draw them, or you can do it manually, as you'll see in just a second. So I'm going to begin the process by creating a new type. Just for the purpose of our demonstration today, I'm going to create a new version of our county. I'm going to call it US counties, just to differentiate what's there already. Now you'll see, again, we have the option to, let me take a space out there, we have the option to define the fill pattern, exactly the same as we've seen before. Solid fill, different types of hatch, etc., different color options. Again, border style can be defined as well. So I'm going to go in this case with a solid fill, and I'm just going to choose a color randomly. Let's choose a bright green color, and I'll leave the border style or black. It says 2 pixels. I'm going to bring it down to 1 pixel here. It's a little narrower, and everything else here should be fine. We'll click OK. Now this will now be added to our list. We now have US counties on our list. This will be available to me either when I'm digitizing or when I assign the feature type for the layer. As you'll see in a second, I can actually define this at the layer level. One other thing to note here, and this is where you can get very creative, as well as assigning a solid pattern. As you can see, we have the color pattern, the fill pattern option that can override what I did before. We also have the option to define a custom fill pattern. This basically allows us to choose an image file, in this case bitmap, GIF, JPEG, PNG, or TIFF file. I'm actually going to use this process right now to show you that I can change the appearance, the default appearance for a feature type that will reflect an image. Now, don't get too carried away with pictures of your cat or pictures of your family, whatever. It'll look kind of strange, but theoretically you could. You could make your polygons look whatever way you want. So we'll just go with this one right now. We'll click open, and we will give it a name. It inherited the name of the file, which is fine. It's called grass. It's just a picture of some grass just for fun. And you'll see now that the US counties layer is now going to be symbolized based on this image that you see down below. Before I leave this dialog box, before we click OK, the other thing to note here is that when you're dealing with feature types, you also have the option to predetermine the attribute structure. In other words, what attributes would typically be assigned to a layer that contains US counters or whatever it is that you have added for yourself. That will save you a lot of work when it comes to the digitizing process and the assignment of the relevant attributes. And again, it will ensure consistency when you're using that particular feature type. The final thing I want to show you here, while we have a lot of these pre-configured feature types, it's quite likely that many of you will not need all of these. Scrub area, for example. Maybe you do occasionally map some scrub areas, but chances are that's going to be very rare. And if that's the case, you have the option to filter whatever data you do not want to have displayed. That will do two things. First of all, it will remove that display from the map, so be very careful removing a feature type that you have already assigned to objects in your layer. But also it will remove it from the pick list, so that long list of feature types that we encountered will be condensed to just what it is you need. That process is initiated here for areas, for lines, and or for points. So for areas, for instance, you'll see a list of all of those different types of area feature that we saw previously, including, I hope, the one I just created, US. I haven't actually clicked apply yet, so it doesn't exist. If I clicked apply, it wouldn't be on this list as well. But needless to say, for whatever feature types you've created, you can leave those checked, remove the ones that you don't need. It simplifies the selection process. We'll go ahead and apply just to be careful, just to be sure that that change actually did apply. So again, going back to area styles, we have a new style, US counties, and it will look like this strange pattern with grass down below, just for an illustration of kind of a creative way to use a fill pattern. We'll click OK. Now, to assign that feature type to objects in a layer, I can do that a couple of ways as well. I can use my digitizer once again. This is almost a repeat of what we showed previously, where we select either one or a group of objects. We right-click, we choose Edit, and rather than specifying the style manually, which is what we had previously done, we choose the feature type. So we can choose US counties is right here. I'm not going to do it right now because I'm going to apply it universally to the layer in just a second. But we could, at an individual level, either singularly or collectively, change the feature type. And in so doing, we would also change the appearance of the objects in the layer. We'll cancel that for the time being. I'll deselect those polygons and we'll go back to the layer where we started. I'm going to double click to bring up my options for the layer once again. Just to remind you, previously we went to area styles and we applied the styling universally. We applied red polygons if memory serves. This time we're going to bypass area styles and we're going to go all the way over to feature types. And feature types is going to give us this drop down. This is where I indicated previously, if you deselect any of the ones that you don't feel you need, they will not appear in this list. So it'll simplify the process of scrolling. Also, I saw one user that had done this, which is a great idea, where you have your own feature types. Obviously they're appearing alphabetical here. If when you're naming those you precede them with a number 1, 2, 3, 4, etc., they will appear consecutively in this list from the top. So it makes the selection of your feature type specifically much easier. They're not scattered throughout the others within this list. So a couple of the kind of workflow recommendations there. What I'm going to do in our case is scroll to my US counties, the feature type I just created, and we'll click apply. And as you can see, we now apply this grass pattern to the entire US. Very poignant, I guess. Interesting thing when we do this, the pattern actually stays the same place. When you move features around the map, it actually superimposes the vectors on top of a static image, which is an interesting way of deploying. It's hard to see the borders, I know, because they're dark, but you can kind of get an idea as to how this process works. So any image of any type can be assigned in this way, but again, be a little careful. Don't use this for your vacation photographs or whatever. Probably won't be appropriate. So one of the other ways of visualizing or distinguishing data, which is actually very appropriate when we're looking at this where it's very hard to differentiate individual counties, is to assign random colors. I mentioned this in the intro. Some of the applications for this would be a simple workflow to differentiate objects in a layer. Very clear differentiate features so you can distinguish them individually. Process of assigning random colors is pre-configured. Under area styles, all the way at the bottom of the list here, assign random colors to features. And you can define the randomness based on a base style, or you can choose your own palette if necessary. For illustration purposes, I'm just going to leave the defaults as they are. Once again, we'll simply click apply to see the results of this. And there we have a quilt, if you like, a patchwork of colors. Now, while it looks like there is a little bit of repetition in these colors, I can tell you that all of these colors are different and they are all randomly generated. We have conducted this process during our training classes where we have everyone use exactly the same layer and everyone's color assignments are completely different. So it is quite literally a case-by-case random process. Now, it is important to stress here that these colors do not reflect anything in the data whatsoever. There's no meaning in these colors other than they are simply a distinction, and it does create kind of an artistic rendering of the country, I guess. I mean, even now we can do a little bit of analysis and see we've got smaller counties over here, larger counties over there. So visually, the polygons themselves are a little bit more easy to differentiate. So we can conduct a very basic level of analysis. However, once again, it's not that meaningful. What is more meaningful is the process of assigning the visual characteristics, not manually, not based on feature type, but based on some variable within the data. So before we initiate this process, I want to close this window for the time being. We will be back here in just 1 second, but I want first of all to take a look at some of the attributes that we have for these counties. Obviously there's a name there. We'll come back and address the name when we talk about labeling as promised. And we have population, we have the area, population density. This is something I actually calculated in this layer. The area, the population divided by total area, giving us a density value, and we'll be using that in one of our workflows in just a second. The state is noted here, the state of each county, as is the region. I think there are 5 or 6 regions covering the US. We're going to use these 2 attributes to create visual distinction within these county polygons. The first one should be fairly simple to understand. We're going to create a representation of the counties in the US reflecting the state within which they fall. So basically it's this recurring attribute that we're going to have displayed. We'll do the same thing with our regions. Now this is actually going to come into play a little bit in a more meaningful way when we conduct our graphing exercise just a little bit later. The final attribute here, by the way, is a population density that I've multiplied by a factor of 100. And you'll see why in just a few minutes. That's going to be a specific attribute we're going to use for a slightly different procedure. So again, just a quick overview of what attributes we're going to be playing with here. Once again, the first one we're going to look at is the state within which each of these counties falls. Our objective in this exercise is to create a map where states are collectively displayed the same way. All of your Michigans will be a certain color, all of your Nevadas will be a certain color, etc., etc. Double clicking once again to bring up the options. Back in area styles where we left off a few minutes ago, and you can see it's still a random color assignment. We want to revert to applying a style based on an attribute or name value, recurring instances, in other words, of that attribute. We're going to pull down this attribute list, and you'll see, as well as the layer characteristics themselves, we have the individual attributes noted here. And what I'm looking for specifically in our first scenario is the state. Couple of ways I can proceed with this process. One is a little more difficult and one is a lot easier. I could, where my cursor is right now, simply click on the new value and enter the name of my first state, Maine, where I'm sitting right now. That process would allow me then to assign the color and move to the next one, New Hampshire, Vermont, etc., etc. Might take a little bit of time to do that, but it is something that could be done. If you want to pre-configure or want to manually configure the assignment of colors, by all means you can do that. What makes this a little simpler, however, is the process of loading values. Now, this works perfectly in this type of situation because we know there are only technically 49 different variables within this attribute called state. Well, wait a minute, you're saying 49. Okay, we don't have Hawaii and we don't have Alaska. Surely that should be 48. Well, we also have the District of Columbia sitting all the way over here, little polygon right there. So it has to have its own color. It's not part of any other state. So technically, that's the 49th. So in this case, there are 49 recurring attributes. All we need to do is simply say load values. Now, when I click load values, the first choice I'm going to be asked to make is what the base color that I want to assign, what foundation color that I want to choose. You can see it has inherited what we did before. It has remembered that I chose a red color and made it semi-transparent. I'm going to move this back towards opaque again. We don't need to have any transparency in this example, but we'll keep this red color and we'll click OK. Now, because it's looking for the recurring instances of each state, it's now asking me if I would like to assign, there's that name again, random color to each style, and I do. This again will assign a random color collectively to every instance of every state. So we'll click yes here, and you'll see in my list that I could have created manually, it has done this automatically for me. These colors are completely random. You sometimes see them skewed, that there's more reds than there should be or more blues. Best way to visualize how appropriate these colors are is to click the apply button. I would typically encourage you not to click OK, which does the same thing essentially, but it closes this window. By clicking apply, we can preview the results on our screen, and you can see the colors that have been assigned. Now, immediately, as a cartographer from a long time ago, I can say that the color of Colorado and the colors that are assigned to New Mexico here would probably be changed, specifically New Mexico, as it's too close to Texas. So you can start to get in and look at individual colors. I'm just going to choose New Mexico as my example here. And right here at the bottom, it has been assigned this green color. I don't know, maybe a red, what is a red here? Maybe a yellow color might look good here. So we can, at an individual level for each of these classifications, change the style. So we'll change our solid green color to a solid yellow color in this case. And we'll click OK. And we'll again click apply to see the results. And you can see that now has been updated. So you can now fine tune those colors. You can completely scrap the colors that were assigned initially and create your own. You can assign your own colors. If there is a specific color that reflects a certain state, by all means, you can use that. Now, obviously, this process is manual and can be a little time consuming, especially in situations where I have 49 different colors to manage. You know, in a case where there's 3 or 4, it might not take as long, but this might get a little more involved. And there's an artistic element to it as well. There's an aesthetic element. If you're doing this repeatedly for the same type of data, you can perform this action once and then save the results in a style file. And that style file can then be loaded and applied to a new layer. Now, situations where that would be appropriate is if you had applied a classification based on a type of data that you know you'll be seeing a variation of in the future. The same variables, the same attributes applied maybe across multiple project areas. So that rather than having to recreate the same procedure and manually assign the colors, both the colors and the attribute assignment will be saved in that style file, and it simplifies that deployment of colors. So you can build a library of styles that you apply based on the attribute data that you know you're going to be working with. So we will actually load a couple of style files in a little bit to show you how that process works. It saves the manual process, as you can see right here. Now, I'm going to click OK to close the window, and I will assume we're happy with the results. We would often, in cases where we create a map like this, also generate a legend. In the case of the US states, it may not be appropriate. I was thinking about this a little bit in terms of preparing this. To have a legend that has 49 different entries, it actually would take up a lot of my screen. There are going to be situations where that would be appropriate, but it might be more appropriate in this case to actually assign labels. So I'm going to cheat just a little bit here, but it will also give us an opportunity to talk once again about one of our display options. I'm going to bring in another layer, and this layer happens to be a layer of US states. And there we can see we have now labels assigned to the US states. I might want to change the font style, might want to make them a different color. I have the separate layer now, so I have complete control over how that looks. So just as an illustration now that we've assigned colors, rather than a legend in this case, maybe a separate layer is the way to do that. I'll go ahead and close the states layer for the time being. Now, the variation on that theme that I talked about based on a region. I'm going to double click once again. I do this because I want to show you how you revert back to the default. This requires you to delete the entries that are in here. If you don't delete them, but they will be retained. So we're going to select the first one, Alabama. I'm going to scroll all the way to Wyoming, holding down my shift button on my keyboard. They're all now selected, and you'll see we have a delete option. While these were added automatically, we're going to manually delete them. And this time we're going to go to a different attribute, in this case region. If you recall, the one we selected, I believe, was Rocky Mountain. Same process as before. Once again, we'll ask Global Mapper to load the values. We'll choose a default color. Once again, remember the opacity setting from the time I did it manually. We'll leave red as is. Click OK. Yes, we would like random colors once again. And as you can see in this case, the random colors are not very random. I might need a couple of blues in here. I'm just going to change this one to a blue color. That almost gave me a headache looking at that one, that pink color. That's okay. We'll click OK. And again, I could probably add a green in there as well. We'll click Apply. And again, we have colors assigned, in this case based on regions. This is just an illustration of two variations on that theme. And I use this example because in this case, a legend would probably be appropriate because there's fewer objects on the map. We might want to display a legend to describe to the viewer of our map or to ourselves what exactly these colors represent. Process of adding a legend can be done a couple of ways. You can go straight to the configuration dialog box or to the view menu, and all the way towards the bottom of the view menu we have workspace layout options, including a map legend. I should say before I initiate this process that if your intention is to print a map for which you have applied colors such as this, don't worry about adding a legend on the screen. You can do that in the layout. We have introduced our layout function in previous presentations. You can add a legend, you can add text, you can add other elements to that layout. You don't need to do that now. For on-screen use, I'm going to add my map legend. It's going to be based on my vector types. I can define the font, etc., various options in here. It will by default place it over here on the bottom right corner of my display. I can change that as well based on the position, but that will be fine for me now. We'll click OK. And there's my legend, Midwest, Northeast, etc., etc., etc. So now we can see those colors and we can see what they mean on the same screen. Now before we proceed to the next workflow, I'm actually going to save this workspace. We haven't talked about workspaces, we haven't dealt with workspaces yet, we've simply loaded an individual layer, but I'm going to actually come back to this display, such as the same display you're seeing right now. So in order for me to do this, I'm going to save a workspace. I'm just going to drop it on my desktop, and I'm going to call it Counties. So I remember to pick this one up a little bit later. The other way of visualizing data is based on not a recurring instance of a text string, region or state in this case, but a numeric value. And if you recall, one of the values we have associated with the objects, the features in this layer, is population density. I calculated as I mentioned. So I want to create a visualization that reflects population density. And once again, it's under the options, under area styles. It has remembered what I did previously, so I'm going to remove the previously selected list. I'm going to hit delete. And I'm going to change to population density. Now, At this stage, I could hit the load values button as before. In fact, I will, just to show you what the consequences of that would be. Typically, it's not as useful because we're dealing with an attribute that has numbers. Not all the features are going to share a specific value. In other words, you're going to have virtually unique values, unique population density values for every polygon. So while we had 49 recurring instances with our states and 6 I believe, recurring instances with our regions, with numbers it's not going to be as well defined. So the process of assigning the color characteristics when you're dealing with numbers, if we click load values, again we'll choose a default, we're going to choose red. It will give us, that's fine, we'll click yes, it'll allow us to give us numeric values, it'll address the fact that numeric values. It will give us the minimum, it will give us the maximum, and it will give us the average value and assign colors by default accordingly. Now, this map by itself would not be very meaningful. Obviously, when you're dealing with numeric ranges, you're dealing with increased value of a particular characteristic, in our case population density. So there is a relationship between each value, an intensity if you like. So what I typically do in this type of approach is create a map that has a single color but increased intensities of that color. If you recall back to this slide presentation when I introduced the agenda, that map on the left side had different intensities of blue to reflect, in this case it's going to be population density. So this initial approach is not really that useful. What it is useful for, if nothing else, is to show you within this data layer the extent of values, my lowest and my highest value. This may help you to determine where to assign the colors and what values to assign those to, because more often than not, this is going to be a manual process where you assign a color to reflect a certain value and repeat that process based on whatever thresholds you want to establish. Now, to cut to the chase here and to make this a little more meaningful, once again I'm going to delete these. I don't want to retain these colors, nor do I want to retain these values. Instead, what I want to do is load a file that I had previously saved, and this is where this process becomes extremely useful when dealing with numeric values, because I can create almost a template for a numeric thematic map, a choropleth map that has number values, and deploy that to any layer that I want. I'm going to load a style file. It's under my webcast folder and it's called population density, and you can see it's got the suffix GM layer style. You couldn't mistake it for anything else. It's obviously very proprietary. We'll click open, and what that does is simply apply colors and apply numbers. And you can see what I have done in this example. It's very simple. I've given a value of 0, a white color, a value of 1,000, a blue color, and you'll note that I've given a value of 1,001, a red color. Now let me explain what's going to happen before we actually click the apply button. If we have a value for a specific county that's exactly 0, it will be a white color. Period. That's it. If we have a value that's exactly 10, it will be the blue color as is displayed here. There's a light blue color, etc., etc. If we have a value that's 1001, it will be exactly red, the same red you're seeing here. Chances are, in this layer with all of these polygons, there are going to be no values that are exactly 0. I know for a fact there aren't. There are none that are going to be exactly 10 or exactly 100, etc. So each of the polygons is going to have a number that falls somewhere within the range that I have assigned. In which case the colors that are applied will be interpolated based on where they fall within this range. So if I have a value of 5, it will be exactly halfway in a color sense from white to this light blue. Similarly, if I have something that's 55, it will be halfway between this light blue and this medium blue. So the colors are essentially interpolated based on the assumption that you have not unchecked this box where we interpolate colors between numeric values. That will be something you will, in most situations, want to maintain based on this process. Now, going up to the upper range of my colors, you'll see I've got 1,000 that's a fairly high population density, by the way. Most of the larger cities will be within that, are close to approaching that value. But I've also assigned a new color, bright red, obviously, for everything that's 1001 and up. So there is no interpolation. There's very little interpolation between these two values. That means that any population density that is 1001 or greater will automatically be assigned this red color. There is no further interpolation. Now, in this example, it helps me to visualize areas which are obviously very high in terms of population density. So with that said, let's click apply once again, and we'll see the consequences on our display. So this is now a reflection of population density, the density of population. Fairly even distribution throughout some of the eastern states here. We move into some of the western states. Nevada, very low population density, as one would expect. The Bay Area of California, a little bit higher. Southern California again. But I find it interesting looking at the northeast area around New York City, Philadelphia, Washington, D.C. area, all very high concentrations of population, high density of population. And the fact that I assign a red color to be everything that's 1001 and above, it clearly makes those visible. Once again, if the legend I had previously displayed on the screen has changed to reflect the new variables. So that layer style that I created, I now have as a template that I could apply in any situation where I'm creating a map or visualization of population density, knowing that these values would be consistent. If I did one same process of Canada or a population density map of cities in Europe, exactly the same layer style could be applied, so I can do a direct comparison. So it's a very, very useful tool. Save the layer style file once you've done all that work manually, which I created these manually before I began. Save that style file. Again, it's a GM layer style, and then load it up as needed. So I'm going to show you a very creative use of our 3D visualization that reflects the same data. We're looking at population density here, and we're obviously looking at a top-down view rendered in different colors. I'm going to actually revert to a standard color for all features. Again, remember what I did before. I'm going to turn this to opaque. I think I'm going to use a different color for this. I'm going to use a standard blue color. Maybe a little bit more of a muted blue. Maybe we'll bring it down just a little bit. It's almost purple. That's fine. Click OK. Click OK. And again, we're going to lose the visual representation of our density in this example. We'll click Apply. And you can see all US counties are now assigned the same color. In fact, I'm going to hide the legend now. We don't need our legend displayed anymore. And we will go to our options and display no map legend. So these features, all of the polygons have a numeric value that we're interested in visually representing, that being our population density. And as I mentioned when I showed you a preview of the attributes, I have a number that I calculated that's actually factored by a value of 100 for reasons you will see in just a second. Just to revisit that once again with our info tool, I'm going to choose one of the counties, and this population density, it says 3, I think I originally said 3D. For reasons you'll see in just a second, I've actually increased this value. So let's go ahead and close this dialog box. What I want to do is I want to pretend that that number value that I've just previewed is actually an elevation value. So I'm going to go to the layer, I'm going to double click, and one of the tabs that you'll see in here is elevations. This is typically where you can assign an actual height value, or if you're using 3D models, a model height value to vector features. And typically if you have an attribute associated with a feature, it may be called elevation or height, in which case this process would be automatic. In our case, we're going to be using this creatively because the attribute value that we're going to pretend is elevation is actually our population density, in fact the one that I calculated. So I'm going to choose that, and I'm going to specify an altitude mode of absolute, in other words starting from sea level. And our elevation value, even though they're not actually meters and the actual unit is not important in this case, we'll leave that as meters. So I've overridden any previous default representation of elevation and told Global Mapper that a specific attribute column is in fact elevation. For reasons you will see in just a second, we'll click OK, and I want to pop up my 3D view. When I do, it will display a very interesting visualization of that population. I don't know if my color selection was appropriate, nor do I think my background is actually working in this case. I think my screen is a little bit larger than it should be, but you'll see that each of these polygons is now a three-dimensional polygon. As you can see right down here, we're looking at the edge of the county, if you like. Moving up to the Chicago area, you can see it almost looks like buildings. In fact, if we head over to the northeast here, you can see the area around the northeast. It looks like an urban landscape almost. But this is a reflection of the value. We're creating a three-dimensional rendering of vector data where the height value reflects the density. When I was looking at this visualization, I happened to notice these spikes. They're in the state of Virginia, and when I investigated further, it turned out that rather than just dealing with counties, certain Virginia areas are actually towns where there's obviously a higher degree of clustering of population anyway. So these are actually towns that you're seeing on these little spikes. But for the most part, these large block polygons reflect urban areas, large urban areas. We can see Detroit over here, and again Chicago, etc., etc. So different way of visualizing data, but it gives you an avenue in terms of the display of vector data to pretend, if you like, that whatever numeric value that you're interested in representing, pretend it's elevation, and Global Mapper will render it as a 3D map. So the next thing we want to do is take a look at the heat map or density map process. Now, density mapping is a very simple procedure where it analyzes either the clustering or the values within a specific attribute and creates a gridded layer based on a shader that reflects increased intensity, if you like. It only works with point data. So obviously in this case we're dealing with polygons. What I'm going to do is I'm going to generate a point for every polygon. So with my counties displayed, I'm first going to select them all. I'm going to use my cursor. I'm going to right click on the layer and I'm going to select all the features. So they're all highlighted now, they're all selected. This is now a digitizer function. So I've got my digitizer selected. I'm going to right click under Advanced Feature Creation Options. I'm going to create a new point at the centroid of every feature. Now when I do this, going to give me an option to either, both move this centroid point if it's outside and to create a single point if they're grouped areas. In this case, we do have grouped areas. There are counties that obviously have islands, and we don't want a point for every island. So these polygons are grouped polygons that will just generate one point for us. So everything else here should be fine. We'll click OK. And immediately we have points where previously there were polygons, these points being in the centroid. You'll notice they're labeled as well, and they're also assigned to our user created features layer. One thing I'm going to do very quickly before we proceed is just turn off our labels. For this layer we don't need labels, so we're going to uncheck the box to display labels as we did previously with our polygon layer. So we just have points on the map now. I'm going to deselect them. Just hit my escape button on my keyboard, and as you can see, it just is a reflection of where those polygons are. There are multiple ways of using this tool, by the way, one of which we're going to visit again in a few minutes when we talk about labels, so we'll hold that thought for the time being. What I want to do is simply generate a density or a clustering map. And I can see immediately, just based on proximity, where the highest concentration of points are. Right over here, look at the southern Appalachians area down into Georgia. Counties are relatively small, so you can see the points are closer together. The density mapping process right here in the toolbar is initiated by this button. And I'm going to leave the defaults as they are for this. This is simply an analysis of clustering. There's no reference to any inherent data. It's simply clustering. We'll click OK. And we generate a heat map. Easier to see if I turn off the underlying map. We generate a heat map that reflects, let me turn off my legend as well. We don't need the legend, that's fine. That reflects that clustering. And you can see again with the points on as well, you can see that's confirmed where the highest clustering is. We can see where those highest concentrations of points are. So that's one example of the heat map process. Probably more meaningful in this case, if I turn on my points once again, wrong layer, is to generate a heat map that actually reflects the data. Now, one thing that happened as a consequence of generating these points, if I select one of the points, you'll notice that all of the attributes that were originally assigned to the polygon have been automatically assigned to the point. So I now have point data that has the same variables, including population. And I want to generate a heat map that reflects this population value. So using the same procedure as before, I'm going to go to my density map tool, but in this case we're not doing it based on a point count, but rather on population. And once again we'll click OK, And this time you'll see that the heat map reflects areas where there is highest population assigned to each of the points in this case, but originally assigned to the polygons. And in this case, it's fairly obvious where the highest concentrations are. Northeast corridor from Boston all the way down to Washington. You got Chicago again, very well defined. Dallas and Houston, southern Florida, obviously southern California, high concentration. Bay Area, and then Portland, Seattle. So you're almost getting a map of the population centers of the US as is represented by a heat map, and we're seeing that concentration. So again, broad theme of today's presentation is visualization of vector data. This is a way to visualize the characteristics of vector data, but using a raster format. In this case, it's a gridded layer, a heat map. Now the next thing we're going to look at is the graphing tool. If you recall a few minutes ago, I saved a workspace just after we had created a visualization of the regions. I'm going to use that as a basis of one of our graphing exercises. What I'm going to do to revert back to that display is to load that workspace. Now, the workspace, as you'll note in my title bar up here, is called counties. It's still loaded. A little asterisk right here beside the name implies that there have been changes to the workspace since I created it, which there has. I've added new layers, I've created my density map, etc. However, if I add the workspace, you can see it noted here in my recent list. It will first ask me if I want to save the current workspace, and I don't. I don't want to override what I previously saved, so I'm going to click no. And then it's asking me if I want to unload all the data before it loads the new workspace, and I want to. I say yes. So basically that's a way of refreshing your current display to the last time you saved the workspace, which is obviously about 10 minutes ago for us. And we have once again our display of our counties that reflect the regions. Our graphing tool allows us to visualize data separately from the map, and there are multiple options. As you'll see, we can create a bar graph, a line graph, or a pie chart, and the pie chart is actually what we're going to use in this example. Once again, we want a pie chart that reflects population. The graphing tool is accessed from the analysis menu towards the bottom, graph and chart manager. Now, when you pop up the dialog box, there's really no options here other than to say new. If we had previously created a graph or multiple graphs, they would be listed here. They would be saved in the workspace. If I saved a workspace with the relevant data and it created a graph, it would remember that and it would be available for me to select, and I could change or modify them as needed. Obviously, I haven't done this yet, so there's nothing available. Click new, and we're prompted with the dialog box for creating a graph. We can give this a title. I'm going to call this population. Or maybe population by region would be more appropriate. If I can type it would be better. G-I-O-N. And we have the option of putting a legend. I'm going to opt not to show the legend in this example, and you'll see why in just a second. We also then have the option of defining the data series. Now basically this allows us to define initially the layer and then the attribute within the layer that we're going to map. The type of graph that I'm going to create here is a pie chart. The source of my data, you can see US states and US counties. I still have the states layer loaded. I want it to be based on US counties. The attribute value is going to be population. Now I'm going to get an error message when I select this simply because of the sheer volume of data. That's fine. It had an error. That's fine. We're okay with that. We'll click OK, because what we want to do is normalize the population by region. In other words, when we choose region, we're going to generate a pie chart that collectively summarizes the total population that's assigned to each of the polygons and displays them with a label of the region itself as well as the value. Now, you can choose which labels to display. I'm initially not going to display any labels, just to make our pie chart just a little bit bigger. And as you can see, without those labels, it fills the entire window. The colors that are assigned are, again, fairly random colors just based on this process. I can choose a custom color, or what's most appropriate is to match the color, because we have driven this from what's displayed underneath on the map. There's my red, my blue, etc., etc. We can match those colors, and you can see why the assignment of colors on the map is important now, because we're obviously reflecting that in the corresponding graph that has been created. I may want to actually enable labels, maybe just to show the value but not the actual region itself. I've got my legend down here in the bottom corner of my screen. That's telling me my regions are. They're fairly obvious anyway. So I just want the value to be noted here. So it still uses a little bit of space, but not a lot. So I can see now the total population. I don't need any decimals here. Let me bring my decimals down to 0. Now, my total population designated as a distribution, the whole population of the country obviously being the whole circle, but this is a pie chart that reflects the population based on those regions. We click OK, and it will initially give us a floating window. This is something that we could deploy previously as a attachment or as an insert into a printed map. We could capture this as a bitmap and put it on a printed map. But now we can have this displayed as a dockable window on our map view itself, and that's what I've done right there. I've actually docked this over to the side. I'll close the graph manager. You'll see the population by region graph is now listed here. I can open and edit it if necessary. We'll close this dialog box, and now you can see this information now displayed. The individual regions noted with my legend and the corresponding population with my color assignments very clearly seen. If I change any of the variables in any of the counties, it will update this in real time. If I assign a county to be in a different region, again, this graph will automatically reflect those new values, either the reassignment to a new region or the new totals of population. So again, we're dealing with visualization of vector data, but this is a way to extract some of the attributes of that vector data and to have that visualized as a corresponding pie chart in this case. Now, my final bullet from the agenda list was a quick look at labeling, and the operative word here is quick. It's not going to be an in-depth look at labeling. When we first loaded the counties layer, we noted that the features had a label assigned. Now, I'm going to do a couple of closings here. I'm going to close my graph. I'm also going to revert back to the original display. So for my counties layer, I'm going to double click, or I'm going to go to options, go to my area styles, and we'll use the default. We're not worried about our regions in this case. We'll click apply just to verify. The default is the feature style that I selected, so we need to also change the feature type. I'd forgotten about that. It's no longer US county. We'll go back to unknown area type, and we'll click OK. So we're back to the way it started. Now, if you recall, when I first loaded this shapefile, it did have labels, and I unchecked the label box for this layer. Let's check it back on again, and we'll see what we get here. So we want to display labels for the layer, if any shown. That's basically the command to enable the labeling process. And as I mentioned previously, as far as labels are concerned, there is a decluttering process that is activated by default. You can turn that off. There's an option under the configuration area to display all labels. I certainly wouldn't recommend it, because you will find in this case that you'll have text sitting on top of other text, so it would not work. But even at this level, you can see that the labeling process is not that effective here, because first of all, the text is larger than the features it's trying to represent. There's text sitting on top of boundaries, etc., etc., etc. So I'm going to show you a creative way to manage labels in such a way that you can individually control them, you can move them around, etc., etc., etc. For this, I'm just going to quickly zoom in to get an initial point of reference. Now, it looks like right about here, the labels start to look reasonably good. As you can see, the labels are fitting nicely inside their polygons, and the display is not, there's pretty much every label is displayed, and there's no text obliterating other text. However, I can't control the individual labels. I'm going to look for an example here. Well, obviously, Wyandotte, maybe? It doesn't really look that good. I might want to change that one. This one, Sarpy right here, I would want to move that up a little bit if I could. Washington, again, a little bit large. Union would probably be moved up here if I could. Douglas maybe moved away from the border. So you may want to fine-tune this a little bit. And unfortunately, when you're dealing with polygons, that's not possible. You can see there's got a little bit of a mess going on here. McCracken might need to be moved down. So what we need to do is create a system whereby our labels are essentially detached from the polygons. In order to do that, I'm going to repeat a process I did a few minutes ago, which is generating a centroid point. Now, this is not something that's documented as a workflow in the help files in Global Mapper, but it's something you can do if you're ever faced with a situation such as this, where you need to manage labels independently. So taking my counties layer, I'm first going to select all of the features once again. They're all selected. You can see them highlighted on the map. Right-click anywhere on the map, doesn't matter where. As I did before, under the Advanced Feature Creation options, I'm going to create new points at the centroid. the label assignment for my polygons was the centroid by default. So this is basically creating a point. Again, we'll have a single point for grouped areas, and we will move the centroid point if it's outside the boundary. So we want to make sure it's inside the associated polygon. And we'll click OK. And you can see we now have our points. Those points are going to be the labels that we will assign for this layer. So I'm first going to go back to what I did a few minutes ago, which is basically disabling the labels for the original polygon layer. We came in quickly and turned them on just to preview how the labels look. Now we're going to turn them off. Click OK. And I have points now that are have labels assigned. Again, we talked about it previously. All of the points inherited all of the attributes, including the label, from the polygons. I'm also going to right click and I'm going to assign these to their own layer. I want to have a layer called labels. The fact that they're all still selected lets me edit them and lets me change the layer to a new layer. And that new layer is going to be called labels. As you'll see, I'll just leave the unknown. Actually, no, while I'm here, might as well do two things at once. I'm also going to change the symbology based on the feature type for these points. Right now, they're once again unknown. All of these black dots are unknown feature types. I'm going to change that to be a text feature type. Now, a text feature type is obviously text, but without a symbol. You'll see a preview here where we've got a selection box, but there's nothing inside. This will leave me just text, no symbol. With these two settings, we'll click OK. We will call the new layer that we're about to create labels. We could call it county labels if we were doing this a little more thoroughly. And confirming the projection, it's the same projection that's assigned to the current base map. We'll just confirm that as OK. And now, as you can see, we have labels that are assigned to the points. I'm going to hit it to deselect them, and are completely independent. They are part of their own layer now. I can turn them off and turn them on. I can also move them around. Now, I'm looking for a couple of examples here. Alexander is probably a good example. I've selected just that one point. I can right-click. I can go to Move, Reshape, and I can move. Now, you'll see there's also a toolbar button that does the same thing. I'm going to tell you a little secret here. Let me back out of this menu. If, while selecting a feature, you hold the Alt button down on your keyboard, it immediately prompts you to move that. So that is a very simple way to edit features. So now I can pick this up and I'll move it a little bit up here so it fits more cleanly inside the bounds. I'm going to look for some other. Fulton right here is probably not in its best location. Once again, with the Alt button held down, I can quickly move this out of the way. New Madrid, I think is how they pronounce this one. I move this down here. So you can see, you can now clean up the map very, very easily, very quickly and very easily. Livingston looks like it needs moved. Each one of these labels is now independent of its polygon. It was generated from the polygon, but it can be independently managed and moved around. And you can really apply some cartographic convention here to the display characteristics. We're still dealing with the idea that this text is defined based on a point size. So we still have this issue when we zoom out that the text is much larger than the polygon that it's supposed to be representing. And a solution for that is to change from being a point size for the text to being a physical size based on ground units. Now, this again is something you'll not see documented as far as a workflow is concerned, but it's certainly something that is an option within Global Mapper. I'm going to choose all the labels once again. I'm going to right click, I'm going to select all. Once again, they're all highlighted. Once again, I'm going to go to Edit. And this time, I'm going to define the specific characteristics of each of these labels based on their font. Now, having done this as a little bit of trial and error, I'm going to define the labels using a fixed height of 5,000 meters. I believe this is right. We will find out, I guess. I think it might be 50,000. I think I may have typed this wrong in my notes. We'll find out in just a second. So basically that's 50 kilometers. Each letter, the tallest letters, will be 50 kilometers tall in ground units. Now we're not talking about point size anymore. We're disregarding the size as we would usually select it. We're saying this P is going to be 50 kilometers tall. We'll click OK, and I hope I've chosen the right size here. We'll find out in just a second. Nope, I was right the first time. Let's go back and we'll edit once again. I should have respected my notes. I should have known what I was doing. Let's go back to 5,000 meters. And we'll click OK. And we'll click OK once again. That looks a little bit better. Okay, so it doesn't look that different than it did before we made this change. However, now these labels are going to retain their size relative to the feature that they're labeling, as you can see. So they will always fit. If I tweak St. Francis here, okay, hold down my Alt button and move this just down a little bit, that will always appear in this section of the polygon. It will not vary. I can also, for the labels, define the zoom level range. Currently my scale, if I note at the bottom, is about 1 to just over 1,200,000. So I'm going to define that as being the threshold range for my labels. I'll double click to bring up the options once again, and under map zoom I only want to show the labels below, again taking this value 1, 2, 3, 4, 5. I think that should be just about right, and we'll click apply. And as you can see, they've disappeared. When I zoom in, they will appear at that threshold. So while I zoom out, I don't need to see labels at this level. Only when I zoom in will that label there actually appear. Maybe a little further out would be more appropriate. But you can see we now have that control. And again, as you zoom around the map, you can tweak the label positioning. Not sure what I would do with Broomfield here. Maybe I would move it outside and have it labeled from the side. But as you can see, Denver probably needs tweaked a little bit here. And you can also change the size of an individual label. And while we defined this based on 5,000 meters, we can make it a little bit shorter, maybe if it needed to fit in a smaller area. So I promised a quick look at labels. We saw how labels behaved by default, and I gave you a quick overview of a workflow that lets you be creative on how you manage labels by assigning the labels to a point rather than depending on where they're placed based on the polygon. So as hopefully you saw over the course of this presentation, there are a number of different ways to change the appearance of vector data, either manually, choosing either the layer level or the feature level to choose whatever colors you want, or line style or point style, whichever is appropriate, but also a number of ways of deriving the appearance based on an automatic process that reflects some of the data or the characteristics of that data. So a number of different workflows. Hopefully you find some of that to be useful. As I mentioned at the start of the presentation, if you have questions about this session, or indeed questions about anything to do with Global Mapper, our technical support crew are ready and willing and able to answer your questions. geohelp@bluemarblegeo.com is the email address. If you have questions about sales, want a quote perhaps, want some information on some of the licensing options, you can send an email to orders@bluemarblegeo.com. And if you're viewing this presentation and you're not currently using Global Mapper, this was obviously just one very specific component of the software. But if you're interested and you want to find out more, maybe you want to follow some of the workflows, you can download a trial. Go to our website, bluemarblegeo.com. You'll see right on the homepage links to the products, including Global Mapper, and you can go right to the Global Mapper page and download. We give you a 2-week trial to kick the tires, so to speak, to see if it works. And obviously you can purchase a license online as well. So thank you once again for joining me today, and we look forward to speaking with you at our next webcast.